Good morning. My name is Gilles Lambert. I'm professor in cell biology and biochemistry in the University of La Réunion in France. And I have been specializing in lipids studies. So as you all know, cholesterol is a cardiovascular risk factor as it deposits in arteries, and it's transported in the blood in the form of lipoproteins. They're round-shaped and they're very rich in cholesterol. It's called for everybody the bad cholesterol because it tends to deposit in the arteries, build up a plaque, and when this plaque is rupturing, eventually it leads to myocardial infarction or stroke. So all people have LDL and they tend to deposit along their lives, but there are genetic conditions where this process is much faster than what it should be. And this is called familial hypercholesterolemia. It's a genetic condition, and it is estimated in the world that 1 person out of 250 has it. So it's not a rare condition. It passes in families from father or mothers to son and daughters. So when one member of the family is diagnosed with FH, it's very important that all the family is seen by a doctor to make sure they do not have it. These people have mutations on different genes that are important in cholesterol metabolism. And these genes are the LDL receptor, which is the main gateway of blood cholesterol inside the liver. So when this gateway is not functioning, cholesterol cannot go in. Or it's not a problem of the receptor of the gate, it's the problem of the key. The key is ApoB, which is the main protein of LDL that is recognized by the receptor. In rare instances, it's mutations on other genes called LDL receptor adapter protein or PCSK9. Patients with genetically elevated LDL cholesterol can be treated. There is hope for these patients. First, they need to have lifestyle habits modification and eat diets poor in cholesterol and lipids. Make sure they maintain a normal weight and also that they do not smoke. Then there is a second line of defense, which is therapeutic. This class of drugs are called statins, and statins will block the synthesis of cholesterol inside your cells. And by doing so, you will reduce the amount of LDL cholesterol in your plasma, and you will not aggravate the process of cholesterol deposit into your arteries. Besides the statin, there is another class of drug called ezetimibe, which blocks the entry of cholesterol from the diet through the gut inside your blood. And in conjunction with statin and ezetimibe, you can reduce LDL cholesterol by up to 60–65%. But for those genetic conditions, for people with familial hypercholesterolemia, this is often not enough. In recent years, a novel class of drug has been developed by pharmaceutical companies. They're called PCSK9 inhibitors. And these drugs, what they do is that they increase the number of LDL receptor at the surface of liver cells, and they allow for more LDL to be cleared from the plasma inside the liver. These class of drugs are not pills, they're injectable, and they are prescribed only in specialized care centers throughout the world to these patients who are the most at risk of developing heart disease because of those genetic conditions that cannot be tackled only with statin and eventually ezetimibe. So, this being said, there is hope for these patients and their cholesterol can reach the therapeutic target goals. Nowadays, with this armamentarium of treatments, it is possible that these patients have the same life expectancy or almost the same life expectancy than you and me. So that's extremely important. Now, there is there are still patients that will suffer heart attack despite these treatments. And there is another genetic condition, and we do not fully understand the metabolism and the pathways of it, which is elevated lipoprotein small a. Lipoprotein small a is a subclass of LDL. It's a type of LDL that cannot be reduced by statins. PCSK9 inhibitors modestly reduce them, but not enough. So new drugs and new therapeutic approaches are currently being developed to reduce lipoprotein small a. Only 20% of the population have elevated LPA, and among these 20%, only 1 to 2% have extremely elevated. And for those patients, actually, currently, the only treatment is apheresis. So they undergo lipoprotein apheresis, which is an extracorporeal procedure to filter their Lp(a) out of their system, like a dialysis. So for those patients, hope is on the way. And that is the development of inhibitors of LPA synthesis. These drugs will appear in the very near future if the clinical trials prove positive and prove safe. So in the field of lipidology, because we learned so much in the past decades about the genetic conditions, the whole community, including pharmaceutical companies, has been able to develop new therapeutic ways to reduce LDL cholesterol, to reduce cardiovascular burden, and to prolong life. But there are still some residual risk associated with this special class of lipoprotein called lipoprotein small a. And this is the subject of extensive research at the moment, intensive research at the moment. This is a subject of huge developments, and hopefully within the next decade we will have drugs to address this genetic condition. Thank you very much.